Hi guys, welcome to my channel mathssl. I'm speaking Latif. I'm going to show you today a theorem, which is the reason of the theorem is line from right angle vertex perpendicular to hypotenuse. The theorem says a line drawn from the vertex at the right angle of a right angled triangle perpendicular to the hypotenuse divides the triangle into two triangles which are similar to each other and to the original triangle. So I need to show you first, this is a question gonna be an exam like this, but the question actually I want to show you, I want to draw the triangle so that you can understand how, then you will understand the question better. So obviously this is a 90-degree triangle, ABC, this is a major triangle. Now if I draw, so a line drawn from the vertex at the right angle of a triangle. You see this is a right angle triangle. So now you need to draw the line. So if you draw the line here from the vertex according to the theorem, so then we draw the line and then is perpendicular to the uh, hypotenuse. So obviously this is hypotenuse for the main triangle. It's gonna be perpendicular, which means gonna be a 90 degree. 90 degree 90 degree. Now divide the triangle into two triangles, so they can see one triangle this side, the other one is that side, and which are similar to each other, which means these both triangles gonna be similar to each other and to the original triangle, which means the major triangle also is gonna be a similar. So I'm gonna explain to you how this thing works. Angle, this is P. So this is your angle 1. So this is 2, and then we have P1 and P2, right? So remember this is your angle 1, and this is your angle 2. So this is the question they will give it to you, that this is going to be a theorem way, definition of theorem, and then obviously this triangle has been given to you, and the given triangle ABC with B angle AC is equal to 90 degree, which means BAC this is equal to 90 degree, and AP, which is this one, perpendicular to BC, right? So obviously left hand side and as well right hand side as well. Now required to prove triangle ABC similar to triangle PBA similar to triangle PAC. I'll show you how to prove this theorem. Now I need to show you how to prove this theorem. Before we prove this theorem, must remember that this is a main triangle 90 degree, and say we have this angle, I make a dots, this angle B and this angle C, I make a cross here, and then I got another triangle which is small one, left hand side, I got 90 degree, I've got common angle dot one, and then this become cross, and then right hand side I've got triangle 90 degree I've got in this triangle as well cross, so I don't have the dot, I make dot this one here. This is very important. So now remember this is angle 90 degree and the B dot and C is cross. Again this triangle, so P is supposed to be also now 90 degree. There you can see 90 degree, and B is supposed to be dot, there is dot, and the A is supposed to be cross, and there is cross, and then come to PAC, and then P is supposed to be 90 degree. Yes, it is 90 degree, and the A supposed to be dot, and there is a dot, and C is cross, and there is cross. So pay attention to the order of the letters, and so these triangles letters in order. So I'll show you how to prove now. So I need to prove these two triangles, they are similar. In triangle ABC and triangle PBA. So have a look. A go with B. So the angle A1 and plus A2 is going to be equal to P1 because we doing the main triangle ABC and then the small one, the left hand side one, PBA. Right. So the angle A1 plus angle A2 is equal to angle P1, which is going to be equal to 90 degree, and that is given. Now, this is my first angle, and I need one more, and angle B. So, main triangle angle B and in this small triangle angle B is common. So, the angle B is going to be equal to angle B, and that's common. And this is my second angle, and the last one I don't need to even prove because that's become third angle of triangle. So angle C is going to be equal to angle A1. This angle C, this one, angle C is going to be equal to A1. This is the third angle of triangle for PBA. So that's the reason is third angle of triangle. This is my third angle. So therefore triangle ABC similar to triangle PBA, and the reason is angle, angle, angle. So there I prove the first one, triangle ABC similar to triangle PBA. Now I need to prove that the triangle ABC also similar to triangle PAC. Remember major triangle and the left hand side. Now major triangle, now we're going to do the right hand side triangle, this one, right? So in triangle ABC and triangle PAC, so ABC angle A1 plus A2 is going to be equal to angle P2. Remember this is 90 degree, this is also 90 degree. So angle A1 plus angle A2 is equal to angle P2, which is 90 degree, and that is given. And now this is my first angle, one I need more. So angle C, this side, ABC, angle C, and in triangle PAC, this angle C is the common angle. So the angle C is equal to angle C is a common. So this is my second angle. The last one is going to be third angle of triangle. Angle B is going to be equal to angle A2. That's my third angle of triangle. This one, angle B, the main triangle, and the angle A2 here. This is the third angle of triangle for PAC. Right. So therefore triangle ABC similar to triangle PAC. Reason angle, angle, angle. So I prove the triangle ABC also similar to triangle PAC. Now I need to prove that these two triangles also are similar. Therefore, triangle PBA similar to triangle PAC. The reason is both is similar to triangle ABC. Therefore, I can say now triangle ABC similar to triangle PBA similar to triangle PAC. We proved. Must remember these both triangle we proved they are similar to triangle ABC. So if they are both similar to triangle ABC, so which means These both triangles also similar to each other. Please subscribe and like my videos. If you have any question, comment below. I will assist you.